All right, so let's talk about electron configuration. Electron configuration is the arrangement of electrons in an atom. So before we talked about orbital diagrams, and up here we actually have a bunch of orbital diagrams, but instead of having to write all this out to describe where electrons go and how they fit into the atom, we're actually going to make it shorthand, and that way we're going to do electron configuration. So let's start with neon. We know neon has 10 electrons in its neutral state. So when I drew the orbital diagram, this is what I got, with 10 electrons drawn out. Instead of having to draw all of that out, I'm going to do a shorthand version and say, okay, in the 1s orbital, we have 2 electrons, so I'm going to make a superscript of 2. In the 2s orbital, I have 2 electrons, again, a superscript of 2. In the 2p orbital, or sublevel, I have 6 electrons, so I'm going to make a superscript of 6. So this is basically electron configuration. All right, so let's do something a little bit more. Let's do sodium. Sodium has 11 electrons in its neutral state. So, okay, awesome. We're going to say this has 1s, 2, 2s, 2, 2p, 6, 3s, 1. Well, there's something special about neon. Neon we know is a noble gas, meaning all the electrons are filled in the outer shell. So this makes it a special kind of atom or element. So down here, this is one more electron than sodium. So instead of having to rewrite this whole thing, notice that this electron configuration is identical to this one. They're the same. So instead of writing this, again, the whole thing, I can just write it, well, sodium has the same electron configuration as neon, plus a 3s1 electron. Easy enough. Okay, let's do chlorine, which has a little bit more electrons. Chlorine, if we were to draw this, if we just simplify this into electron configuration, we'd say, okay, chlorine has a 1s2, 2s2, 2p6, again, same as neon. So instead I'm going to write neon, 3s2, 3p7. So this is the electron configuration for neon. We're going to call these two, this one and this one, the noble gas configuration. Okay, so which is the same thing as electron configuration, it's just a little bit shorter and easier to write, easier to manage. But what if we come across an element that has 87 electrons, such as francium? That is a ton of electrons, and I don't want to have to draw all this out. This is just a pain. So an easy way to do this is if you look at the periodic table, here's francium right here. The noble gas before francium is radon. Radon has 86 electrons. Francium only has one more. So we're going to say, okay, let's make it easy on ourselves. Let's say it has one more electron. Awesome. So I just have to notify or notice where's the electron coming from and how am I going to denote that? So francium we know is in the 7th period. So we're going to say, okay, great. It's actually, we're going to put 7 there. And everything in group 1 ends in an S1. So we're going to say, okay, great, 7s1. If we were to talk about something, let's say, let's do sulfur. Sulfur, notice it's in the 3rd period, so the noble gas configuration would be neon 3s, and then we go over to the p's 1, 2, 3, 4, p4. So sulfur, if we were to write it, 16 electrons. It would be, what did we say, neon? 3s2, we don't forget we have to denote that, 3p4. Pretty much easy enough. So that is electron configuration and noble gas configuration.